Okay, class. Good morning. So we want to move on to method of sections. I strongly encourage you to watch the previous videos to get a strong understanding of how to calculate your support reactions, because that's very important as we move forward. Um, okay, so we're actually to determine. Well, let me just back up. When it comes to method of sections, again, you can use method of joints to still um, evaluate or analyze a particular frame. But what if you have quite a few members? You have AG, AB, BC, CD, DE, EC, GE, CG, BG. So these are a lot of members to really calculate or try to evaluate. So one trick to use is what we know as method of sections. Okay, and the idea really is you're doing so if you're not trying to find out um, if all the members are in tension or compression, you're just trying to find out just a few of them rather than all of them. What you can do, you can just cut a section of that particular structure and look inside and evaluate whether that member is in tension or compression. Okay, so again, the idea of method of sections is not to calculate or try to analyze each member within a frame, but you use method of sections to evaluate just certain frames or certain members within that frame. Okay, so for instance, we have a frame here, and we actually determine the forces just only in GE, GC, and BC. Okay, and if I may erase this part right here, so we actually just find what are the forces in GE, okay, GC, okay, and BC. Okay, so nothing really changes in terms of our approach. Um, we are going to draw a free body diagram, which is what I have right here. Okay, and then our next step is to really calculate our support reaction. Okay, so in doing so, I can do my moments about point A and take clockwise to be positive. And when I do that, I'm going to we're going to have 1,200 newtons times 8 meters. Okay, and then we have this 400 newtons. I'm sorry, um, times 3. That's going to be a positive 400 newtons times 3 meters. Okay, and then we have our dy minus dy, and that's going to be over a value of 12 equals 0. So our dy, you do the math, it's going to be 900 newtons. Okay, so what we can do now, we can take it a step further and just kind of jump and just you can say some of the forces in the x direction equals 0. Okay, I'm taking, again, class, I noticed in your work, you don't put these directions there. They're very important. You have to put that. You have to let the reader know that you're taking from left to right to be positive. Okay, so all the force in the x direction, I have a negative ax here. I have a positive 400 newtons. Okay, and therefore my ax, so I solve for ax, equals 400 newtons. Okay, I want to take it a step further and say sum of the forces in the y direction equals 0. Okay, and I'm going to look for all the forces in the y direction. I see ay here, positive, minus this 1200 newtons coming down, and then plus this dy, which is 900 newtons, equals 0. Okay, and then my ay, of course, would be 300 newtons. Okay, so I have all my support reactions. Okay, AY, AX, and DY. Okay, so my next step really now is to step number 3. I'm going to bring this diagram back up again. Okay, and then what I'll do is I am going to make a cut, because again they want us to find the forces in the member GC, in the GE, member GC, and in the member BC. So in doing so, what you can typically do is when you're trying to find the members in GE, try to find the forces in GE, GC, and BC. Again, with method of sections, you're going to do what you know as a cross-sectional cut. Okay, and in doing so, what's going to happen is you're getting rid of this section of the problem. You're just exposing the internal component of it. Okay, so it's going to look something like this. Okay, so this is, everything is going to be in tension. This is going to be my force GE. This is going to be my force that was going to be CG. And then this is going to be force, that's going to be force BC. Okay, so I just kind of left this point here to kind of help us um, as we move forward. Okay, so right now all I did was did a cross-sectional cut. Okay, and all the forces leaving these members are in positive. They're in tension. I'm sorry, they're all in tension. Okay, so in doing so, now what I can do is I can apply my equilibrium, my equations of equilibrium to this particular aspect of the structure. Okay, so again, this is still point C though. Okay, that's still point C. Okay, so now what I'm going to do is I'm going to take the moment about point G. Okay, this is point G right here. Okay, so when I do that, I have I'm going to have my AY is still 300 newtons. My AX is still 400 newtons. Okay, so this is about point G, and so I'm going to AY is going to be take my moment about point G. It's going to be AY times 404 meters. Okay, and then I have a 400 Newton here, and that is 3 meters away from G, and that's going to go positive, plus 400 newtons times 3 meters. Again, I'm taking the moment about point G now, so I'm looking at all the forces. I have another force here, and that is going to be 4 meters away. I'm sorry, this particular force is no longer there again, because that we erased that part, that component of it. Okay, this is just okay. So we're looking at all the forces here. Now we're looking at let's look at BC. BC is a force, and that is 3 meters away. Okay, bring that here, and it's going to give us negative FBC times 3 meters. Again, and my AY is nothing more than 300. Okay, and this equals 0. So my FBC happens to be 800 newtons. And that's going to be in tension. Okay, so all I'm doing is taking the moment about point G, and I'm looking at all the forces that I can multiply a distant arm to give me a moment from point G. Okay, so once I've done that, I can now go on and say, okay, well, I still need FCE and FGC. So what if I do moments about point C? Now this is my point of interest right here. Okay, so when I do that, again, these are all invisible, okay, to that point. So moment about point C, now I have my AY, which is 300 times 8, 300 newtons times 8 meters, right? And my FGE, this is my FGE, it's FGE, so FGE is 3 meters away from point C, right? So that's going to be plus FGE times 3 meters, and that equals 0. Okay, whereby your FGE equals 800 newtons, and it's going to be in compression. It's going to be negative. Okay, and then lastly, I can, since even if I were to break this up into my X and Y component, we can just solve really some of the. We know that um, this is a vertical component. This is another vertical component. We don't have any other horizontal components, right? Other than this AY. So we can do some of the forces in the Y direction equals 0. And we have here our AY. Okay, and then this FCG, right? We know from this diagram above here, we know this is going to be, it's going to be 4, it's going to be 3, and this is going to be a 5. Okay, so the vertical component is going to be 3/5, right? So that's going to be our AY minus 3/5 FCG equals 0. Well, we know our AY happens to be 300, right? So it's 300 newtons equals 3/5 FCG. And I can solve for FCG, and that happens to be 500 newtons. And that's going to be in tension. Okay, so I hope this helps. Again, this is just another method, another way of solving or trying to evaluate whether your members are in tension or compression. Again, you're using the method of sections just to be able to analyze just only some of the members within that frame, not all of them. Unlike the method of joints, you use that technique to find out whether all the members are in tension or compression. Again, unlike the method of sections, you're only just choosing just a few of those members to evaluate to see whether they're in tension or compression. Okay, I hope this helps. Thank you very much. Bye-bye.